Hello, everyone. I'm Faisal from Lancaster University. I'm here to, thank you for the introduction. I'm here to present to you exploring interactions with physically dynamic bar charts. This is some work done with my colleagues John, Abhijit, Christian, Yvonne, Kasper, and Jansen. So the aim of our research is to look at how people might want to interact with a physically dynamic information visualization, such as a bar chart. So we want to combine the power of information visualization with the innovative potential of shape-changing display technology. So we developed a prototype system called Emerge. This is a 10 by 10 physically dynamic bar chart, and I'd like to start by showing you a short clip, which would hopefully which should demonstrate some of the capabilities of our system. So here we go. Okay, so as I mentioned at the start, we were looking at interaction techniques with information visualizations, such as physically dynamic bar charts. And we looked at the potential of shape-changing displays that could achieve something like this. So to structure the interaction techniques, we looked at here in Schneiderman's taxonomy for visual data and analysis. But of course, this taxonomy covers a wide range of tasks. But we don't really know how people might want to interact with the physically dynamic bar chart, so we need to start somewhere. So we picked the fundamental tasks from this taxonomy. These are filtering, navigation, annotation, and organization. And we developed techniques for these tasks. We carried out a user evaluation with 17 participants. But before I go much more into depth, with the user evaluation and the interaction techniques that we developed, I'd just quickly like to run you through the architecture of our Emerge platform. So at the bottom, we've got some slider panels. These are motorized potentiometers, which are essentially repurposed audio DAC sliders. These are connected by mechanical linkages to some plastic rods, which are essentially the bars of the bar chart. We've also got full-color RGB LEDs, which individually illuminate each plastic rod, a Connect to pick up touch gesture interactions, and a projector to show axes information. So as I said, we carried out a user study with 17 participants, and I'd just like to go over the procedure of this. We initially collected some demographic information. But before we showed users any of the interaction techniques that we developed, we wanted to know how they would like to achieve a task like annotation. So we asked them to carry out a subtask like select the year in which a country had the highest amount of electricity consumption. So following this, after getting their impressions before showing our techniques, we then demonstrated our techniques. And then asked them to carry out a second subtask, which might have been something like find the country with the smallest amount of electricity consumption. They were then asked to rate the interactions that they carried out, and this was repeated for each of the 4 tasks from the taxonomy that we used: filtering, annotation, organization, and navigation. Yeah. So at the end of the study, we had a semi-structured discussion with them to find out how they felt about the interactions. So I'd just like to go over the techniques now and what we found from the user study. So annotation might involve selecting a specific bar because it might be interesting, so the highest value on the bar chart, for instance. So we developed 3 techniques for this. One being the point technique, in which the user can point on the axes. This selects via crosshair the bar that they want to annotate, and the rest of the bars become dim, and the one that they're selecting stays illuminated. Secondly, we looked at the pulling technique, where you simply pull one of the bars in order to select that particular bar. Thirdly, we looked at the press technique, which is just pressing the bar. So, what do we find from the user study? So, participants initially, before they viewed these techniques, said they would prefer to just press the bars. And this fell into line with the technique that they would prefer after viewing our techniques. We found that it was quite important to have the feedback from the annotation techniques, where all of the other bars became dim and the one that they are selecting stayed illuminated. And they also said that pressing felt the most intuitive for them. So next we'll look at filtering. So filtering involves, so if you want to compare a couple of rows on your bar chart and you want the rest to hide away, how might users want to achieve this? So the techniques we came up with firstly involved a swipe style technique, where you swipe on the axes and then that particular row hides away. Next, we looked at a more physical interaction where you manually mash down the bars on the bar chart in order to hide them. Next, rather than pressing the bars all the way down, we looked at an assisted press where you press the bars a small amount and then the system detects the press and then hides away. We also looked at press shortcut technique, where if you want to hide single rows, you press the bar at the end, and then that hides away that particular row. Finally, we looked at press to compare technique, where if you just want to compare 2 rows and you want to hide the rest away, you press down on a bar on each of the row, in each of those 2 rows, and then they stay up and the rest is hide away. So from the study, we found that participants stated before viewing these interactions that they would like to do a touch gesture style interaction in order to carry out the filtering task. But after we showed them the techniques, it was more of a shift towards the physical interaction preferences. So to hide the bars, they stated they prefer to use the press shortcut technique, where you just press on the end of a specific row and it hides the entire row. And also for keeping just 2 rows, for instance, they'd like to use a physical press technique. So we also found that it was quite important to combine the hiding and keeping the rows on the bar chart, because you sort of want to avoid repetitive actions. So you don't want to keep hiding away bars if you only want 2 rows to stay up. So next we'll look at organization. This is rearranging the rows, for example. If a row is quite far away from you, and what might you want to do if you want to bring it closer to you? So we looked at a drag technique, where you drag on the axes and that shifts a specific row to where you want it to be. And we call this instant drag because the 2 rows instantly switch over. But we were also interested in whether showing some sort of transition would help users to see that the organization was taking place. And we also explored this with a physical style interaction. So we looked at pressing down on the bars of 2 rows in order to switch them over. And we also experimented with a transition phase in which users could see that the bars would the travel of the rows once they press down on them. So we found that their initial suggested interactions before they viewed these techniques matched how they'd prefer to interact with the bar chart after viewing our techniques. We also found that transitions were not liked by our study participants. They felt it took too long and it didn't really and it was quite confusing to see the movement of the confusing to see the physical transition taking place. And for example, if used in a presentation scenario, one of the participants stated that if they made a mistake and tried to reorganize the wrong row, they'd have to wait till that happened and then try and rectify that mistake. So next we look at navigation. So what happens, because this is a 10 by 10 interface, what happens if you've got, say, rainfall information for a specific country over a couple of hundred years? So how might you want to scroll through? Well, first technique we looked at was that using a scroll technique. This was a projected scroll bar which users could use in order to shift through the information. Next we looked at a more fine-grained technique where projected buttons could be used to shift rows left and right, well, by one row. Next, a more physical technique where you press on the actual bars to shift the rows left and right. And finally, a paging technique where the rows shift by order of 10. So basically, 10 rows move in order to page. So again, the proposed technique that users wanted to do before they saw our techniques was to use a scroll, and this matched what they wanted to do after viewing our techniques. We found that it was quite useful to visually show what was happening when the user was scrolling through, because it showed all the values that occurred whilst the scroll bar was reaching its destination point. This allowed participants to look at trends over time, for example. So, from our investigations, I'd like to discuss a few things. We identified both we found that both physical and gesture-style interactions were quite useful, and they had benefits and shortcomings. So we found that bigger actions were actually more suited to gesture-style interactions. So organization, for being an example, where if you have a row quite far away from you, having to move it closer to you is more suited to a gesture-style interaction. Whereas smaller actions like annotation, we require to simply select an individual point, are more suited to physical interactions. And actually, this is a really good finding, because we were worried that users would, our study participants would feel like they were interfering with the values of the bar chart if they were shown that they could interact with the actual bars. But this was not the case at all. So we found, like, for example, on the annotation and filtering tasks, that they actually liked to press the bars. And it's quite important to combine fine and more coarse-grained control. So examples being with filtering, hiding rows versus keeping rows. So you don't want to be repetitively carrying out an interaction. And with navigation as well. You might want to look at trends over time, but you also might want to compare individual rows and use a more fine-grained control method. So general perceptions, how did they feel about the physically dynamic bar chart? We found there's quite a lot of influence from touchscreen style interactions, touchscreens being a huge part of our everyday interaction. So we use a smartphone, we use a tablet on a day-to-day basis. And this heavily influenced. So I think this is something that we need to think about when we develop or when we design physically dynamic bar charts or physically dynamic information visualization interfaces. And we looked at some of the movement and behaviors that participants had around around our eMERGE platform, and they would sometimes they would move around the display or change their posture in order to get a better view to look at trends over time and compare two rows, for example. There was also a surprise factor that the actuation speed is an important design consideration, because if the actuation is way too fast, this might increase the surprise factor. And if the actuation is way too slow, users might become impatient. So of course we had some our investigations were limited to a specific set of tasks, but we wanted to scope our work and look at the fundamental interactions that can be performed on a physically dynamic bar chart. And this is, of course, based on one possible form of bar chart implementation, shape-changing bar chart implementation. We also excluded reading values from the height of the bars, because there's many ways of doing this, and we want to explore this as part of future work. And for this paper, we basically wanted to scope our investigations. And like I said, this is part of future work. And the fact that the participants like to physically interact, we would also like to explore more physical interaction techniques. So to wrap up, we identified useful interactions that involve both gesture-based and physical interactions. We found that tasks like annotation and filtering were more suited to physical, whereas organization and navigation were more suited to gesture-based interactions. We believe we successfully set a groundwork to explore more complex interactions, so combining annotation with filtering, for instance. It was also good to find that participants successfully identified trends, so when comparing rows and identifying the high values and low values. And an important finding is the feasibility of physical interaction with the actual bars, and the fact that they didn't feel they were interfering with them. So I think there's very good potential in using shape-changing technology to do information visualization. And I'll end on that note. Thank you all very much.
Hello, I'm Daniel Leitinger from the MIT Media Lab.
Oh.
I'd be really interested in what were your more like informal observations were when people were interacting with the data that
Yep.
was physicalized. So things like how were they using their body to maybe find high and low points? Were they like, you know, maybe putting their hand down to see which pin would poke them first? Or also things like that were maybe not part of the study, but maybe when you were showing it to people, you noticed like how people discuss data when there's like 2 or 3 people gathering around the display to use it as a physical reference.
Yep.
Just
Yeah, that's an excellent question. So some of the informal findings, like I said, there was of course a surprise factor from the actuation. I mean, from the demographic data and from talking with the participants, they had never seen a shape-changing display before, especially in the context of a bar chart. So there was that surprise factor from actuation. And to compare rows, for example, they would switch their posture to kind of get a better look at the bars. And also, I think your final point was, I can't remember, but I think I know the answer to that. But the system, when there's more people, when there's more people around the system, actually, the system invites into interaction in a way that people are always wanting to kind of prod the bars. It just feels like it's an automatic reaction. Even people from our group who have seen shape-changing displays before. But yeah, don't know if that answers the question.
thank you.
Thanks.
Lane Harrison, WPI. This is great work. So now that you have tangible and interaction for data visualizations, have you thought about maybe running a control study with 2D?
Yep.
And it seems like a tangible might change the types of questions that people would ask in an exploratory data visualization task. Is that something you're going to look at?
Yeah, definitely. So, for example, we're interested in looking at how people interpret height values and things like that, and I think that's a good baseline to do more comparative and controlled user studies where, you basically give them the physically dynamic interface and a 2D bar chart, for example, and look at how they carry out the task. That's definitely part of future work.
Awesome, thanks.
Thanks.